All right. This is Winter 15, paper 4-1, question 4. A binary abstract data type ADT has these three associated operations. Create tree, add an item to the tree, add, and output items in ascending order. So there must be some sort of working. I told you that binary tree is associated with one of the sorting thing as well. Show the final state of the binary tree after the following operations are carried out. Create tree, add Dodi, add Ferrari, add Ellie, add uh, George, Ben, Celine, Ali, whatever. So let's see how it works. So the first thing is Dodi, and we don't have any tree. So what happens that we enter Dodi as root. All right. And then we have Farai. So F is bigger than D. So Farai. Third one is Le. So bigger than D, lesser than F. And then we have George. George is actually bigger than D and bigger than F. And then we have Ben, lesser than D. So it would go on this side. And then we have Celine, lesser than D, greater than C. So it would be on the right side. And then we have Ali, lesser than D, lesser than B, it is Ali. See, so in latest papers, you have to create it yourself. All right. Now, 4 marks. The binary tree ADT is to be implemented as an array of nodes. Each node consists of data and 2 pointers. The data is name, left pointer is integer, right pointer is integer, and type. The statements declare tree as an array 1 to 10 of node. Of node means this. Okay? The statement declare tree array 1 to 10 of node. Reserve space for 10 nodes in array tree. Any issue with it? The create tree operation links all the nodes into the linked list of free nodes. Actually, hota kya hai? This is actually coming from your book, the CIE book. It defines these data structures mostly with linked list. When you go to the codes, you would see the link is given. In the Visual Basic codes, we have one folder, A2 data structure codes from the book. So all the data structure codes which are given in the book, I have listed them here. They all are made, and there are certain codes which are having trouble, so I have corrected those as well. All of it, whatever the code that you see in the book is there, so you can download and practice it. And all the errors are removed. So they are in A2 level codes and then A2 data structure codes from the book. You'll find binary there as well. Okay? So now, what is a linked list? Let's just start doing linked list sidewise. Linked list is a collection of nodes. But these nodes are, beta, zara khamosh rahiye. पे अटेंशन. अब यहाँ से ना आखिर के 3 घंटे शुरू हो रहे हैं और ये बहुत टफ है. जितनी कंसंट्रेशन हो सकती है कर लें, पढ़ के भी समझ नहीं आएगा वो बुक में. The difference between other data structure and linked list is this, that all other data structures are having nodes in grouped form. In linked list, these are all scattered in the memory. So we have to have links. So when we have a list and there is no data in it, we call it free list. What do we call it? Free list. As soon as we start creating a list in it, so we will be producing a new list out of the free list. So these are now two different lists. In the same area, a list is being created, a free list is being used to create a list. So free list is shrinking and free list and other list is increasing in size. So reserve spaces for 10 nodes in the array tree. The create tree operation links all nodes into the linked list of free nodes. It also initializes the root pointer and free pointer. Root pointer means the address of the node from where the whole thing starts. ठीक है? Address of the node where the whole thing started. And free pointer, it is the next available node out of all listed nodes. ठीक है? Show the content of tree array. This is the array. And the values of two pointers. Root pointer and free pointer after the operations given in part A have been carried out. The root तो भी है ही नहीं हमारे पास. There is no root at all. So what would be the value of it? 0. A free pointer would be. All right. But we have to put all these values first. All right. So what we do, we have all this Dodi, Ferry. I told you, as soon as you find them, you just put them in the name or the data. I explained it, right? 10 minutes earlier. So let's just first solve it. They say after the operations given in part A, means they have emphasized on it. After the operations given in part A has been carried out. So Dodi Fry Ellie George Ben Celine and Ali. And if you think of that tree, it would be, you have to actually create it. I'm keeping this in mind and I'm creating this. All right, I'm keeping this in mind. What is on the left, what is on the right. So now the root pointer is 1 and the free pointer is this one. Which one is 8? Okay, but left pointers are these as well, because these are now belonging to the empty list. Okay, So that is how it would work. Now let's do it from the fresh. What happens when the whole thing starts? Root pointer is 0, free pointer is 1. And all the left tree nodes are linked. How? This links to 2, this links to 3, this links to 4, this links to 5, this links to 6, 7, 8, 9, 10, and 0. So you first put the value Dodi. Okay? And then comes for I. It would be on the right side of Dodi. Okay? For I would be on the right side of Dodi. Leave what is in the middle. We will look into it. Then comes Ellie. Ellie. Yeah, let's copy that as well. Hold on. Okay, I have copied it so that we don't have any problem with it. So Dodi, then comes Farai, then Ellie, then George, then Ben, then Celine, and then Ali. What is on the left of Dodi? Ben. Where is Ben? Number 5. So this is 5. What is on the right of Ben? Celine. Celine is 6. The right side of the Ben would be 6. What is on the left of Ali? Ben? Ali. Ali is 7. So Ben's left is 7. Then we have Dodi. What is on the right of Dodi? Farai, that is there. Left Ben, that is there. Let's take Farai. What is on the right? George. George is 4. So put 4. And what is on the left of Farai? Ellie. Ellie is 3. That's there. All right. And rest would be 0. This remains Celine. On the left of Celine, there is nothing. There, on the right of Celine, there is nothing. So this would be 0. And same goes with Ali. Same goes with Ellie. Same goes with George. So this is updated form. So that is how we came up with this 9, 10, and 0. This is from the free list. All right, get the idea? If you don't know the linked list and how the linked list is linked in a binary tree and it is only in the left side, you would never be able to create this in this form. So remember, when the array is initialized of composite data type binary tree, which is being implemented using linked list, only the left subtree is linked as a free linked list, which we call free list. Let's go further. Get the idea? Left subtree is linked. A programmer needs an algorithm for outputting items in ascending order. To design the program, writes recursive procedure in pseudocode, part C. Complete the pseudocode. Traverse tree is itself the procedure. That is why they are calling it recursive. It is calling itself. So if the tree root dot left subpointer is not equal to 0, then traverse the left side. The name is tree. Tree root dot left pointer. And then whatever the data at that will be output. Tree root dot right pointer dot name, sorry. Dot name is given anyway. ठीक है? Tree root. We are at the root. We have to output everything. Acha. This was left pointer. Then we have to check for the right pointer. If tree root dot right pointer not equal to 0, then traverse tree right pointer. Every time it is reaching left, right, left, right, left, right, wherever it is reaching, it is outputting the value of it. And that is how the whole tree will be read. Okay? So if tree dot root pointer root dot left pointer is not equal to 0, then traverse tree, अब आप वहां पर आ गए, traverse tree को आपने जो value भेजी है, now it is root. Do not think that this root is like root. For every number they are using the parameter root. For every number they are using the parameter root, because when they are sending the value, it is being received in root. All right, so we will send the root as 1. If t1 dot left pointer is not equal to 0, then traverse the left t dot root dot left pointer. Now it will go with 1. At 1 we have for I. Okay? And according to the values that we have updated in the table, all values will be output. Okay? So this is hard. You have to actually be very much understanding in this. The right guideline would be from the book, the Cambridge book. When Cambridge book starts, they start with these all different data structures, and as soon as linked list appears, they explain linked list, and afterwards every data structure is being uh, introduced in terms of linked list, and whatever that you see there is appearing in exam. So from, let's say, page 615 to page 630, around, maybe a few pages less or more, these are very important pages in that book. This ends around like 628 or 630, I don't remember exactly, but yes. Next question. Explain what is meant by recursive procedure. Give a line number from the code above that shows procedure traverse tree is recursive. Okay? A procedure that calls itself, it is defined in terms of itself. I told you, whatever you, और आप ये भी लिख सकते हैं procedure that is calling itself, वो सब कुछ चलता है, ठीक है? और a procedure that is calling itself from within its body, सब चलेगा. सबसे बेहतर ये है कि it is defined in terms of itself. Line number 4 and 9. Line number 4 and line number 9 is actually telling us that this is recursive, because the name of the procedure is traverse tree, and if it is being used here, it means from within its body it is calling it traverse tree. Write the pseudocode call required to output all names in the tree. देखें, आपके पास यहाँ पे root pointer है, means a global variable which is having 1 in it as the root pointer. ठीक है? So how do we make a call? We will make a call. We will write traverse tree. हमारा सिस्टम स्लो हो रहा है, एक मिनट रुकेगा. ट्रैवर्स ट्री और उसके अंदर आप लिखेंगे रूट पॉइंटर. To solve traverse tree, root pointer. Finished. Same. All right. This is summer 17. Summer 17. 4.2 question 2. An ordered binary tree abstract data type has these associated operations: create tree, add new. This is 17. Last one was 15. Add new item to tree, traverse the tree. Traversal means reading. Reading as in whatever the order that we have, traversal. The binary tree ADT is to be implemented as a linked list of nodes. Again, only left pointer will be linked. And the last node would be null. Each node consists of data, a left pointer and the right pointer. A null pointer is shown as 0. This is 0. Explain the meaning of the null pointer. What is the meaning of null pointer? A variable, a pointer that does not point to another node. A pointer that does not point to another node. That's it. That is the last pointer in the list. A variable which is a pointer and it is not pointing to any other node. The following diagram shows an ordered binary tree after the following data have been added: Dublin, London, Berlin, Paris, Madrid, Copenhagen. Route pointers to Dublin, Dublin to London, London to Paris, Paris to whatever. So you see it. Another data item to be added is Athens. Make the required changes to the diagram when this data is added. So Athens कहाँ आएगा? डबलिन के लेफ्ट पे ए, बी के लेफ्ट पे ए, ठीक है? सो यहां आएगा. ठीक है? Now, a tree without any nodes is represented as this. Remember, free list. Unused nodes are linked together into a free list as shown this. You see, only one side of it is linked, which is left. Right side is always 0. That is why I said on the left. This is the concept that you have to bear in your mind. Now, the following diagram shows now what they have done. I will be making it right away from this. ठीक है? Root pointer 0. Acha. Since now you see that we have got this position 0 here, we cannot make our null pointer 0. We have to make it -1 then. ठीक है? So 0 हम यूज कर सकते हैं, लेकिन बेहतर आप नहीं करें क्योंकि 0 हमारी अपनी पोजीशन है, हमारा रूट 0 होगा. ऑब्वियसली अब हमारे पास ये जो है 7th पोजीशन ये हमारी फ्री है, तो हम यहाँ पे फ्री पॉइंटर में 7 डाल देंगे. अब हम इसको देख लेते हैं. 2 1 -1 3 6 5 4 -1 -1 Madrid, -1 -1 -1 Athens भी last था, -1, and this would be 7 would be pointing to 8, 8 would be pointing to 9, and 9 would be -1, and these rest would be -1 because these are unused. This is as per the diagram. This would have linked earlier before entering this data. So यहाँ पर 1 होगा, यहाँ पर 2 होगा, 3 होगा, 4 होगा, 5 होगा, 6 होगा, 7 होगा, 8 होगा, 9 होगा और -1 होगा. So ये वहीं पे रह गए और ये सारे -1 थे. इसमें जो एडजस्ट हो गए वो हो गए, बाकी छोड़ दिए. याद रखें, शुरू में ये सब इनिशियलाइज होते हैं, सिर्फ लेफ्ट वाली जो नोड है वो लिंक होती है, जैसे अभी ऊपर उन्होंने तस्वीर में दिखाया. राइट वाली हमेशा नल होती है. हटा दें. Should we go forward? Give an appropriate numeral value to represent the null pointer for this design. Justify your answer. -1. Why I have chosen -1? Because the 0 value was there as a location index of the array. I cannot use 0. I used -1. So now this is a tough one. Look at this. Node is a record. See, data type is what? Record. Abstract data, UDT, user defined data, composite. Left pointer integer, right pointer integer, data string, tree array, array of that composite type. New data item that needs to be entered. Free pointer which is pointing to the next available node. Root pointer where the whole scene started. New node pointer stores index of the node to be added. Create tree is subroutine. Add to tree is a subroutine. Create tree is what? Create the tree, initialize root pointer, initialize free pointer, initialize the left sub tree side of it so that all the nodes are linked to each other as a free linked list node, and all the right side will be -1. That is how the tree is created. Find insertion point. I don't know what it is. Procedure that finds the node where a new node is to be added. Procedure takes parameter new data item and returns two parameter. Index, whose value is the index of the node where the new node is to be added. Direction, left or right. So it is telling that go to this node and add it. I think it is actually being taken in new node pointer, and the direction is left or right. D1. Oh, अपडेट ही नहीं हो रहा, पता नहीं क्या हो गया, इतना स्लो मर क्यों हो रहा है। ये देखो मेरा क्लिक तक अभी 10 हो रहा है। जी नहीं, इसमें तो बिल्कुल भी एप्स नहीं है, मेरे पास अपडेट के चक्कर में फंसा हुआ है। अच्छा, so type node and type. So we have to create that abstract data type, left subtree, right subtree, and name. So this would be left pointer, right pointer. Declare left pointer as integer. Declare right pointer as integer and declare name or data as string. Declare tree of array 0 to 9 of what node? Procedure create tree. Declare index of integer type. Root pointer at the start is equal to what? -1. And then we have free pointer. It is always to the first node, which is 0. Now we have to link all the nodes in a loop. This would be from 0 to 9. And then the 9th node would be -1. We would do it ourselves at the end. So tree index dot left pointer is equal to index plus 1. And then tree index dot right pointer would be -1. And then we have to adjust the the 9th one. Tree 9 dot left pointer is equal to -1। अब तो मेरा ख्याल है समझ में आ गई होगी चीज ना, ठीक है? आर वी गुड?